Okay, chapter 4.3 is about discounts and markups. And a discount is a decrease. Means it's when you buy something and it's on sale and so the price goes down. That's a decrease. And a markup is an increase. Okay, if it's a really hot day and you're selling bottles of water out on the street where there's no drinking fountain, you can actually mark up those items. You can increase it, and people will buy them for even more than what they might. You might sell a water bottle for $2 instead of just 50 cents, and that's a markup. And sometimes we want to talk about the percentage of the discount or the percentage of the increase. And we have this old formula that we need to remember. A equals P times W. A is the part of the whole. This is like what we get, the answer, when we multiply a percent times a whole. And a percent can be a fraction or a decimal. Okay, so we say 50% of $100 is $50. 50% times $100, if we were to have that in, then the part of a whole would be $50. That's the part that's left when we apply a percentage to a whole. All right, so that's a little confusing, but we'll be able to work it out. Example number 1 says that there's a pair of shorts. These are not very good looking shorts, but they are $35. And the discount is that they're 25% off. So they're 25% off. And so we look at this equation over here and we say, well, how do we make that work? Well, the percent is 25. So we've got A is equal to 25% times the original price, which is $35. And then we can go ahead and rewrite that using either a fraction or a decimal. We could do 25%, which is 25 over 100, which is the same as 1 over 4. 1/4 times $35. Or we could use A is equal to 0.25, which is the decimal for 25% times $35. Okay, so if I use the fraction, I get 35/4, and 4 goes into 35 8 times with $3 left, so it's 8 3/4, which ends up being 75 cents. It might just be better if we plug this into a calculator. 0.25 times 35. So we've got 0.25 times 35 equals 8.75. So in either way we do it, A is equal to 8.75. Now that's the part, that's the discount. See, this happens to be a discount where 25% off means that we're saving money. So it's not that what we need to make sure we understand is that the shorts don't cost $8.75. They're discounted $8.75. So that gets us to the second half of the problem. The second half of the problem, let me make a straight line instead of a crooked line. The second half of the problem has to do with what we do. Well, we take our total, the sale price. The sale price is equal to the original price, which is $35, minus the discount. And the discount is this $8.75. So it's really $35 minus $8.75. And again, we can go to our trusty calculator. You can actually do that on paper pretty well. $35 minus $8.75 equals $26.25. So the sale price is equal to, I don't even remember what I said. I forgot right away. $26.25. $26.25. So you have to decide whether it's worth it. Now, you didn't want to pay for it at $35, but you're willing to pay for it at $26.25. So that's a discount. That's a decrease. Okay, for example 2, we're finding an original price. And they give us an example where they have shoes on sale. The shoes are 40% off, and now they're $33. Now, there's some price out here that we don't know what it was. There's some original price, and we have to know that there's 100% of the original price is the original price, and they took 40% off. So they're subtracting 40% from 40% from 100%. So that leaves 60%. So we're going to use our equation back to it. That's our percentage equation, percent of a whole. This is a percentage equation. All right. So our percent ends up being 60%. 60% off of some number gives us the new price. So they subtracted 40% of the price, but we're going to use 60% to figure out what the original price was. And this is sort of confusing, but they took 40% off, which means they subtracted 40%. But we're going to use multiplication. So A is equal to 60% or 0.6. 60% is 60 over 100, or it's 0.60, or it's just 0.6. That's the simplest way to write it. Okay, times the whole, and we don't know what the whole is. We do know, let me go up and erase this, we do know what the A is. The A is what the price is now. It's $33. So when we're setting up our equation, we want to start with the percentage equation, A equals percent P times W, A equals P times W, and then figure out what we have and what we need to solve for. W is the thing we have to solve for. So we divide both sides by 0.6. And we can go up to our calculator for that. 33 divided by 0.6. 33 divided by 0.6 is 55. So the original price is $55, and they took 40% of $55 to get our 33. And we could actually draw a little picture of that where 100% is $55. Okay, and half of 55 is like 27 and a half. So that would be like 50%. But we took 40% off of that, so that's going to be taking off something smaller than 50%, and that's going to put us up. That'd be like 60%, and that's going to be around $33. And I think that makes sense. And we just want to make sure that there's some logic here. We're finding a number that kind of fits in. Okay, example 3 is finding a selling price. Okay, finding a selling price. So the store pays $70 for a bicycle. So they get the bicycle for less than what we get. So we have a bicycle. We'll just call it a bike. $70 that the store pays. Okay, so the store pays $70. But they have a markup. They don't want to sell it for $70, or they've done a lot of work and they didn't get any money. They have to sell it for more than $70. And they have a markup, their markup of, they just use this all the time, of 20%. So they want to sell it for 20% more than $70, so that they feel like if they're making 20% off of everything, then they can survive. So we write down our percentage equation again. A equals P times W, and we want to do this every time because it helps us remember it, helps us remember how to use it. This is our part, this is our percentage of the whole. So we have a markup of 20%. So that goes right in there. I'm going to put our markup 20% times the whole, which is $70. And then our final price is actually going to be more than $70, but a 20% is going to be smaller than $70. So what we want to kind of figure out is kind of what we're doing here. If I take 0.2 over 70, this might be one of those times where it's nice to see it done as a fraction. 2/10 times 70 is the same as, cancel those, and 70 tenths is the same as 7 ones. And then 2 times 7 is 14. So the part of the whole is $14. So 20% of 70 is $14. Let me just show you 0.2 times 70 on a calculator so you'll believe me. 0.2 times 70 is $14. All right, so here we have a problem again. Our markup of 20% is $14. But we still have the 70, so we have to go through our selling price is equal to the original price, or the cost to the store is what the book says. This is what the store has to buy the bike for, plus the markup. Okay, so the cost of the store was $70 and the markup is $14. So the selling price is 14 plus 70, or $84. So all of this is to tell you that the selling price of a bike that costs the store $70 is $84. And that's actually not a bad deal. I would think that some stores actually mark up a lot more than 20%. I'm not sure about that, but it kind of depends on the product. Anyway, good luck on this lesson. It should be kind of fun.